Hello there, welcome, warm welcome. Thank you for joining. Get yourself ready. You're going to want some graph paper if possible. Otherwise, grab your notebook, a pen, or a pencil. Whatever you choose to write with is fine. This is math from the void. Math coming at you, pretty much out of nowhere. Today we have a problem from the 1997 Calculus BC exam. Yes, BC. So if you're an AB, this problem would be quite difficult. You could study this topic in some capacity, but you're not going to expect any kind of question involving parametric equations on the AB exam. That would be a BC tested topic. In any event, give yourself some time to do this one. I want to admit this one is very sort of basic, but it's a long boy. We have 5 parts here. So just keep that in mind. Pace yourself. And if this is the first question on the exam, imagine that. You open the free response section and the first page is a 5-part problem. Fun. They do mind games with the AP exam, I'm telling you. A lot of it is mind games. So you need to play mind games to solve this. Give yourself like 12 minutes, maybe 15 minutes. And then when you're ready, come on back. Join me in the deep space. And we'll take a look at how this is done. Let's get started. So first of all, this is parametric. It's saying during this time period from 0 to 6, we got a particle moving, we have an x equation and a y equation. Now I'm going to be perfectly honest with you. You need to immediately recognize those as significant. And what you also need to do is you need to think about what you know of cosine and sine, like just a flash of what you know about cosine and sine. What's the first thing you think about when you think about the graph anyways? This one usually starts up, this one usually starts middle, or at 0 if you like, the midline technically. So what you should do immediately is you should go straight to this graph, and if you don't have one drawn, you can take the time to draw a graph. Make it like 6 by 6 on the x and y, positive and negative. Or I guess that means like make it 12 by 12. Yeah, go 6 in each on each positive and each negative on both axes. You know what I mean. And the first thing you want to do is you want to plot the 3 on the x and the 0 on the y. And you should know that this is going to go in some kind of, a round or cyclical pattern, because cosine and sine are periodic. They're both periodic, so they're going to repeat, basically. So I think we can understand what this is going to look like. This graph goes a little further than I need you to draw yours. We know that it's going to cross through here, right, as an ellipse. Now, how do we know for sure that it's this nice ellipse, that they're both sort of behaving at the same pace? That's because the inside is the same. In fact, you don't really have to know this, but the frequency is pi. Physics people, if you know, you know. Alright, so they're repeating with the same frequency, and therefore they have the same period. We would just call that the b value sometimes. They have the same b value, therefore they have the same period. That's a great thing to mark on the exam, and you can even put like t equals 0. And then the next natural thing to look for is the period. So that's what I'm going to look at. 2 pi over the frequency is the period, so 2 pi over the b, that's just 2. So that means this is going to repeat every 2 seconds, and you'll notice this goes from 0 to 6 seconds. So it's t equals 0, and t equals 2, and t equals 4, and t equals 6. So it cycles a few times. Which direction does it go? I know this is not being asked directly right now, but it's great to have this as a foundation so that you can reference it constantly, and it'll help you understand certain questions along the way. Well, cosine starts positive and then goes towards 0, Sine starts 0 and goes towards positive, so the y needs to be going positive. So we're going to have this general direction. It's going in this general direction, okay? Okay, great. Let's get started with part A. Find the position when t equals 2.5. That's pretty easy. Just plug in 2.5, right? So that means x of 2.5 is going to be 3. Remember, 2.5 is also 5 over 2. Cosine of 5 pi over 2. Well, 5 pi over 2, cosine of that is 0. 3 times 0 is just 0. Okay. Not too bad. Let's look at the y value. Y of 2.5, that's going to be 5 times sine of 5 pi over 2. Now, you'll notice 5 pi over 2, because I know you're familiar with your unit circle, because you have no business watching this video or trying these problems if you can't do the unit circle. I'm being serious about that. You know that that's the same location as pi over 2. So this is going to be 5 times sine of pi over 2, basically, which is 1. And so we have the location of 0, 5 at 2.5. And this kind of makes sense, right? Because it's going to go around the whole cycle at 2 seconds, and then it's going to finish one more quarter of the cycle in half a second. So here's point A. Or I guess point from part A, I'm just calling it. Maybe I should rather label it as t equals 2.5. It's also t equals 0.5. But in this context, we just want to identify it as t equals 2.5. Okay, part B. On the axes below. Oh, well, look at that. I wasn't even looking at that, to be honest. I haven't read these parts of the problem, so I'm just kind of solving it along with you. Yeah, I mean, I knew I was going to have you sketch it at some point, but I didn't realize it was part B. Sketch the graph of the path of the particle from 0 to 6. And we've kind of done that. It just repeats, so you don't need to like draw it 3 times. You can trace it if you want, but you really just have to sort of indicate the direction. And I think it's useful to point out these repeated times, especially that this one is like the final time of 6. So I think that's pretty much done. Yeah. It's very rare that they're going to give you parametric equations and not have you graph them. But even if they didn't have you graph them for some reason, that's where you get a lot of information about what's going on with the function. So just a good idea to do that. You might have to eliminate a parameter, maybe not. Oh, part E. Did you find this easy when you did it? I wonder if you found this easy, since you're watching this afterwards. How many times does this particle pass through? So I just want to know a number of times. How many times does a particle pass through the point found in part A? Well, we know that it crosses, so let me relabel this. We know that it crosses at 0.5, because that would give us pi over 2. And then it crosses again at 2.5. And then it crosses again at 4.5. Really what they did is they made it go a specific speed so that the rotation is happening without pi, but just like it would be on the unit circle. You know, this is, instead of pi over 2, this is just 1 over 2. Instead of pi, this is just 1. Instead of 3 pi over 2, this is just 3 over 2. You get it? So 6.5 would not be reached again, because our time goes from 0 to 6, of course. So it looks like 3 times. It's very simple. 3 times. And notice these don't really say like support your answer, but you should have support for it. And it should be labeled on the graph when possible. That way it's very clear exactly what the heck you're talking about. Otherwise you have to type or write a bunch of stuff out like, as you can see from this or from that. Alright, find the velocity vector. Now the velocity is the derivative of the position. These are position vectors. The derivative, of course, is the velocity. So the velocity vector is going to look like this. This is x prime with respect to t, comma y prime with respect to t. Yeah. So we really just have to find the derivative here, and that's pretty easy to do. This is just going to be like a chain rule situation for each of them. Be careful, because you know that the derivative of cosine is negative sine. Definitely don't want to miss points on that. And then we have a chain rule. So you're going to multiply additionally by pi. And then for y prime, we're just going to have 5 pi cosine of pi t. So like I said, it's a long boy, but there's pretty simple steps. They're like one step. That was one step, honestly. Or 2 steps if you count each derivative separately at any time t. And that also makes sense because they can only award you so many points per problem. They're all weighted the same, each problem. So if there's 5 parts, you know, there's some of them are only going to be worth like 1 point. Like this one, this is probably worth 1 point. These derivatives, probably with 2 points, maybe. That's the max it possibly could be. And part E is finally the formidable part of the problem. Write and evaluate an integral expression in terms of sine and cosine. That gives the distance the particle travels. So we need the distance from t equals 1.5 to t equals 1.25 and t equals 1.75. What is the total distance traveled? What do you think we got to do? Well, just from 1.25 to 1.75 is nice, because we could get a little confusing if it were to like repeat or trace over itself for a while. Like wouldn't need to necessarily do that. But in this case, 1.25 to 1.75, we could also think of this as 5/4 and 7/4, by the way. It's essentially having us find the distance that's covered like along that portion, and not including these little sides either, like just that portion. But those are the reference angles of basically 5 pi over 4 and 7 pi over 4. Okay, so how do we find that? It stands to reason that it would just be a quarter of the whole thing, but we don't know what the entire circumference is. So let's just use the good old distance formula. We're basically going to take an integral, which adds a bunch of stuff up. What are we going to take the integral of? We're going to take the integral of the distance equation. What is the distance equation? Well, it's going to be the square root of the change in x squared plus the change in y squared with respect to time, of course. And that might seem tough, but I'm going to just attempt it without a calculator anyways. I'm sure it'll be fine. We have a sine and we have a cosine. It's kind of promising because I have to square both of them. So here we're going to have the square root of, what does that turn into? I guess it's like 9 pi squared. Yeah, 9 pi squared sine squared pi t plus 25 pi squared cosine squared. Whoops. And I guess, does that mean that I can't quite get a sine squared plus cosine squared equals 1 sort of thing going on here? Now, I don't believe there are any elementary methods. Sorry to call it elementary, but that's what this level of math is, to be honest. There are not any nice elementary methods other than using what's taught sometimes in a geometry or trigonometry class. There's like a calculation that you can use to approximate the length or circumference around an ellipse given these radii. So we have like 5 and 3. But it would be kind of hacking the problem. I'm not sure that we're allowed to do that. So I think you would just want to calculate this on a calculator. Yeah, because for example, if I took out 9 pi squared, sine squared plus cosine squared, I would have 9 pi squared plus 1, but then I would still have 16 pi squared cosine squared pi t, which is not nice to take an antiderivative of. There are some general forms that you can use. Maybe someone in an integration bee would do it. But other than that, let's see, if I were estimating it myself, we have 3 and 5, and the angle here is pi over 4. So let's see, 3, 5. I would say like 5.5-ish, somewhere around there. I know it's a little bit less than the square root of 32. Yeah, just because it's not quite circular. So you'd use a calculator for the end there. Didn't realize this was going to be a calculator problem. Sorry about that. Didn't warn you. All right. Well, there's our particle motion problem. What they asked of you was actually, rather basic. There were just a lot of parts to it. My advice is always to be prepared to solve or eliminate the parameter and solve for an equation y equals fx or something like that if possible. But usually when you have sine and cosine, that's a great hint that it's going to be an ellipse or a circular problem. Label as much as possible from the get-go. Extract as much info as you can. And then some of these questions become very, very easy. Well, that's enough blab out of me. I'll catch you guys next time in the void.